This is the screencast for section 4.4, example 6. We're going to construct a sinusoid by transformations. So we want to construct this sinusoid that rises from a minimum value of y equals 5 at x equals 0. Okay, wait a second. So I'm picturing this in my head. I may as well draw an example here. 0, 5. So x equals 0, y equals 5. So that is a y-intercept. Got it. To a maximum value of y equals 25 at x equals 32. Okay, well this is just going to be a sketch, but basically if I have an x value of 32 out, my y value is going to be all the way up at 25. This is going to be 32 comma 25. And this was the minimum of the sinusoid. This is the maximum. So we actually have another another half of the curve to go before we complete a full period of the curve. So from 0 to 32, that's half the period, which means 64 is the period. All right, the height of the curve, this whole stretch, it goes from 5 to 25. So that's a whole stretch of 20, which means the amplitude is 10, half the height. Well, the last problem I started out with y equals sine of x because that just made sense for the shape of graph we were dealing with. However, cosine is also a sinusoid. Remember, we've already worked on that. Cosine, you just shift it over a little bit and you get the same thing as a sine curve. If I look at this curve carefully, I see that there is a minimum that crosses through the x-axis or the y-axis. So maybe a cosine curve is a better fit here. But instead of, see, the normal cosine curve has a maximum that crosses through the y-axis. How do I make that a minimum that crosses through the y-axis? Yeah, I'm going to start out with y equals negative cosine of x. That's my starting platform. So now I've got a cosine function that is flipped over the x-axis. That's a good starting point here. Now I've got to stretch that out so that its period is 64. So 2 pi times 1 over some number is going to be 64. So I'm going to multiply both sides by b. 2 pi equals 64b. Divide both sides by 64. And you get pi over 32 is the b value. So now, instead of this curve stretching from 0 to 2 pi, it's going to stretch from 0 all the way out to 64. It's going to cover one whole period. And that's going to be y equals, we're still going to leave the negative and the cosine there, of pi over 32x. So we've changed the period. Now it's got a whole big stretchy thing going on, but it's still not in the right place. We need to, instead of stretching it horizontally, now we need to stretch it vertically. See, the amplitude of this curve is 10. The amplitude of the one we've got so far is only 1. So I need to put a 10 in front of that. So now let's see, I'll go over here. Y equals negative 10 cosine of pi over 32x. So now I've got a curve that's nice and stretched out, goes all the way out to 64. That was bad. Goes all the way out to 64. Problem being, it's not shifted up. See, this guy's minimum is going to be negative 10. I want the minimum to be 5. So to shift something from negative 10 to 5, I need to shift it up 15 units. So I'm going to do y equals negative 10 times the cosine of pi over 2x, and then a vertical shift up 15. Now I'm going to take my time to set my window on that curve. This curve is supposed to stretch from 0 to 64. I'm going to put my x min as negative 1 and my x max as 65. Now, it doesn't matter what you scale your x-axis by, 1s, 10s, it doesn't matter. Your y min, though, let's see, it's supposed to go from 5 to 25. Well, I want to see a little bit below the x-axis, so I'm going to go from -5 all the way up to then 30. And I'll see how that graphs. So now you can see a very similar resemblance to the sketch that we drew. This graph has been stretched out horizontally to match the period correctly. It's a cosine curve that's been flipped over, so you've got a minimum on the y-axis instead of a maximum. You've got a vertical stretch by 10, so it has an amplitude of 10. And we've also shifted it up so that its minimum, or its range, goes from 5 to 25 instead of -10 to +10. The now try problem is number 69. We got to look and find the expression of this sinusoid again, but now all we're given is a picture and your window, basically. So if your x-min and x-max are 0 and 2 pi respectively, that means this is going to go 0, this is going to be pi, and then this is going to be pi, and then this is going to be 2 pi. So this completes 2 periods in a length of 2 pi. So the period of this function is pi. Well, if the period is pi, that means 2 pi times 1 over this b value is going to be pi. Now, I know most of you are like, oh, it's 2. Okay, but let's solve just to make sure. Multiply both sides by b. 2 pi equals pi times b. Divide both sides by pi. And sure enough, there it is. B equals 2. All right, so I've got the b value. Oh, I totally skipped over the amplitude. Look at how, so my y min and y max are -4 and 4, so I can tell that each one of these goes by, each little mark here is 1 unit. So if I mark the y-axis, I can see that this curve stretches from -2 to 2, which means its amplitude is 2, so the curve is actually going to have an a value of 2 as well. Now, the last problem we used cosine. What do you think is going to be the best fit for this one? Should we start with a cosine curve or a sine curve? Notice it crosses through not at a max or min, but right through the center of the curve, just like sine does. So I'm going to use a sine curve. So I have y equals 2 times the sine of 2x right now. And then this curve is going to pass through the point 0, 0, and as it's written right now, if I plug in 0, it will pass through the point 0, 0. I don't have to worry about a vertical shift up or anything. This is it. Y equals 2 sine of 2x, and of course you would want to check that on your calculator using the same window that the book provided for you to make sure your graph looks exactly the same.